Today we'll be discussing the issue of sleep. We'll talk about the physiology of sleep, the control of sleep, the effects of a lack of sleep, and the challenge of getting enough sleep, particularly in a hospital setting. Sleep is truly a remarkable state. The average person spends approximately 25 years of their total life sleeping. And as much as we've learned about sleep over the years, the exact function or purpose of sleep remains largely unknown. It was once believed that sleep was a period of physiological rest and inactivity of the body and of the brain that occurs in response to a reduced sensory input. But within the last 50 years of research into sleep, what's been revealed is that it's actually a highly organized and active state generated by a cooperative interplay of many behavioral and also neuronal components. So, for a healthy adult, one night's sleep will typically be approximately 6 to 9 hours long, and it will involve multiple cycles of sleep, which will alternate between two states that we call REM or REM sleep and non-REM or non-REM sleep. The stages of sleep are described using three primary measures: the EEG, we also use eye movements, and we use muscle tone. The waking state is associated with what we call low voltage, high frequency, and very fast activity on the EEG. We also see voluntary movements, eye movements, and voluntary and high muscle tone. So based on these measures, EEG, eye movements, and muscle tone, sleep is subdivided into 5 stages. Stages 1 through 4 comprise our non-REM sleep, and stage 5 is our REM sleep. REM sleep and the 4 stages of non-REM sleep differ dramatically in many ways. We'll be discussing the differences between these stages in terms of our 3 measures over the next few slides. Keep in mind, REM sleep encompasses about 25% of overall sleep time. And in terms of dreaming, dreams occur in both REM and non-REM sleep, but the content and the quality of the dreams are very different. REM dreams are relatively long. They are primarily visual. They often are very emotional, and they are usually not connected to the immediate events of the everyday life of the dreamer. While non-REM dreams are shorter, they're less visual, they're less emotional, much more conceptual, and they're usually much more related to the current life of the dreamer. So we're going to look at these 4 stages of sleep with respect to the changes that we see in EEG and also other changes in the body. So if we go to looking at the stages of sleep, 1 through 4, and then REM sleep, which is our stage 5. With respect to EEG, what we see is stage 1 sleep is actually the transition between waking and the sleep state. Okay? And it's a period in which sleep is thought to be imminent, but not yet developed. And during stage 1 sleep, the EEG exhibits a decrease in high frequency activity that's very characteristic of the waking state. And this reduced cortical activity, okay, is what is typical of stage 1 sleep. Okay. In stage 2 sleep, we see the first true stage of sleep. Okay? Stage 2 is the first true stage of sleep, and we describe this as being light sleep. And in this stage, what we see with the EEG are what we call these spindle-like waves, and also something that we describe as K complexes. You can see a big one there. And these K complexes are slow, synchronized oscillations in neuronal activity between two brain regions, the thalamus and the cerebral cortex. Okay. So, in terms of the EEG and sleep, this random activity represents more higher levels of wakefulness or closer or lighter levels of sleep. And the more we see these sort of large amplitude synchronized oscillations, like is typical of this K wave, that represents that synchronization, those oscillations represent greater, a deeper level of sleep. Okay. Now, during this stage 2 sleep, what we see is muscle tone decreases, the eyes slowly roll back and forth, and respiration becomes more regular and it slows down. And we also see body temperature beginning to fall. With stage 3 sleep, you begin to see these high amplitude waves that we call delta waves. Okay? These delta waves signal a further reduction in arousal and this increase in synchronization of activity between the thalamus and the cortex. And once these delta waves occur at greater than 50% of whatever time frame you're looking at, now at that point, the person is described as being in stage 4 sleep. Now, during stage 3 and stage 4, respiration continues to slow down, become more regular. Heart rate also continues to slow down. The muscles continue to relax, and temperature also continues to drift downward. Stage 3 and 4 sleep are associated with the release of several hormones, such as growth hormone, that are critical for tissue repair and cell turnover. So it's because of the release of these hormones and this activity in stage 3 and 4 that non-REM sleep is often referred to as restorative sleep, where the body heals itself, where the body repairs tissue, and you see the cell turnover. From stage 4, the person then moves into REM sleep. And in REM sleep, as you can see here, the EEG activity decreases, the eyes dart back and forth very quickly, and almost complete loss of muscle tone occurs. Right? So REM stands for rapid eye movement. So this rapid eye movement is the characteristic feature of this stage 5 sleep. We also see body temperature continuing to fall, and the dreams that occur during this REM sleep, as I mentioned earlier, they become much more vivid, much more visual, and often more bizarre and unrelated to the person's life. So over here, what we see are the sleep cycles, multiple sleep cycles, seen from a different perspective. So we see the cycling of sleep stages over about an 8-hour sleep period. And what we see is that we go through one after another sleep cycle. Okay. And you can see at the top here that it takes about 90 minutes to an hour from the onset of sleep to move through all 4 stages of sleep and to all 4 stages of non-REM sleep, and to then move through and complete the REM stage of sleep. We also see that the stages of non-REM sleep move deeper and deeper into the sleep state and farther away from the waking state, with stage 4 being the deepest stage of sleep. And then interestingly, as the body moves into stage 5, the REM sleep, we actually get closer to the waking state. You can also see that the average adult will spend less time as the night progresses, as this 8-hour night progresses. The person will spend less time in those deeper stages of sleep, okay, and will overall spend more time closer to this waking state. What's not represented here is a very common phenomenon of night wakings that often occur at two particular times. We see night wakings between stage 1 in the waking state, so at the start of a cycle, and then also we often see night wakings between REM and the waking state, so at the end of a cycle. And these night wakings can be very brief. They actually often are not even remembered, and the person can roll back into another, either restart the sleep cycle or roll into the next sleep cycle. So the graph panels beneath the sleep cycles show different aspects of body activity, like eye movements and head movements, okay, heart rate and respiration. And as you can see, body activity by all of these measures is lowest at the deeper stages of sleep, and they're at their greatest during this rapid eye movement or REM sleep. So REM sleep, these different periods of REM sleep over the course of the night, represent this time of greater overall body activity.